Hello. We're about to begin our next unit, and a lot of what we're doing within this unit starts talking about using the coordinate plane in connection to some formulas that we've encountered, like Pythagorean theorem, slope. And so I wanted to make sure we understood exactly how we use the Cartesian plane, coordinate plane, what is an ordered point, etc. Before we got into the actual unit itself. And so as you're looking at this, our objectives students will be able to define a coordinate point, coordinate plane, slope, and three forms of equations of lines. The vocabulary you're going to hear fairly often is Cartesian coordinate plane, coordinate point, slope, and equation of a line. And so the first thing we need to truly understand is what is a coordinate point. Coordinate point is an ordered pair . Okay, so order does matter. It starts with an X and it goes with the second entry is a Y. And these things end up being a pairing or a relationship between whatever I put in the X has to go with this value of the Y. And so, again, order matters. The X-axis, as a reminder, is your horizontal . And I think of this as a cross. And sometimes you can see this with an X. And so the X-axis is here. The Y-axis is your vertical axis. And I kind of think about this as a yo-yo. Why? Because of the Y's there, and a yo-yo kind of goes up and down only. And so here's the y-axis. And if you think about this in terms of what these really are, is it's the intersection of two number lines. The origin, which is 0, 0, is the point of intersection. And so when we're plotting any single point, let's just say, for example, we have the point -5 and 2. What this is really saying is travel along the x-axis -5 units. Because we understand number lines, if this is 0, 0, then to the left would be negatives, to the right would be positives, and then along y-axis, +2 units. And so it's sort of like the combination of these two things. So I go along, here's -1, -2, -3, -4, -5. So it would be this x value combined with going along the y value to the +2. So here's 1, here's 2. And so where those two parts intersect is the coordinate point, -5, +2. And again, I understand that this may be review for some of you, but we just want to make sure and clarify before we get into the unit any possible misconceptions we may have. So some brief practice. I'm going to let you pause the video, and then we'll go back through and we'll put some answers. So pause. And welcome back. And so as we go through this, you kind of have to analyze what kind of scaling you have. So I noticed that not every single dotted line here has a number on it. So it looks like 1, 2, 3, 4 dotted lines before I get to the 1. So each one of these is really worth a quarter. So here's a quarter, 2 quarters, 3 quarters. Remember, 1 quarter is 0.25 or 25 hundredths. We could rewrite this fraction as a half, and etc. And so as you're looking at each of these coordinate points, you kind of have to make sure that you're following along with the grid. So F is the point 2, 1, because on the x-axis I go 2, on the y-axis I went 1, and where those two intersect is 2, 1. G, 1, and then this is 2, and there's 3, and it's in between those exactly, so that's 2.5. 0, because I went nowhere along the x-axis, and I went up to 1.5, and K, 2.5, and 1.75. Now, you might be wondering, well, beyond math, where do people use these? Well, all of navigation is really on a grid. You've got your longitude and latitude. If you're thinking about these in terms of like a two-dimensional plane, that a map would be an example of that. And so if you're a ship trying to navigate around islands, you may plot a course. And those points end up being very valuable to you as you try to avoid the islands. And so if you think about this, you could make a line for each one of them, and then you just have to give the spots where you're going to start and stop using that line. Or you could give the points that you're connecting from one to the next to the next. So like this is 5 and 1.5. This is 3.5 and 3. This is 2 and 4.5. Notice how I keep going to the x-axis first. This is 4 and 6. That's 5.5 and 7.5. And this coordinate point is 7.5 and 9. So that's just the basic review surrounding coordinate points, the x and the y. As a reminder, it's just like your alphabet. In case you forget which one goes first, x, y, z. Next, we want to talk a little bit about slope. And so we have basically straight lines, and we can figure out a constant slope. The slope of a line can be described as positive, negative, 0, or undefined. So we want to give you a visual representation of each of those vocabulary words. So slope, this would be positive. And the way I kind of remember that is everything goes left to right. And if my little person is running uphill, then it's positive. If my little person, say, was running downhill, that's negative. And if you think about what is between the positive numbers and the negative numbers in our number line, so if this is up and this is down, this would be neutral. So this is 0. And my little man cannot run up this wall. You can climb it with like a rope and some belay hooks or whatever, but you cannot climb or run up that. So that's what we consider undefined. Okay, and how does this relate to your slope formulas? Well, there are a few. A lot of times we see slope with the symbol m. And I know many of you have heard rise over run. You may have heard of the change in y over the change in x. That's what the delta means, delta, but it means change in. And you may have also seen the formula y2 minus y1 over x2 minus x1. This formula right here is going to be a very commonly occurring concept in the next unit. Okay, now how does that relate back to what we have with these slopes of the lines? Well, if you think about this, this has a positive change in both the x and the y values because of the positive change vertically and the positive change horizontally. And this has a positive change horizontally, but it's going to have a negative change vertically. And so a negative divided by a positive is negative. And where this may help you guys understand what undefined is, if you remember what undefined is when the denominator equals 0. And so if I think about this, this can change vertically, up or down, but there's no change horizontally. So if I look at my formula, that means I have a change in y, but I have a 0 change in x, and therefore it's undefined if the denominator is equal to 0, and we see that right here. Likewise, if you are looking at this, this has 0 change vertically, and it has a change x or y, but 0 divided by some number is just going to be 0. Okay. There are 3 different forms of the line. We're going to focus on the slope-intercept form initially, but definitely eventually get to the standard form as we have to rewrite things. Slope-intercept form is y equals mx plus b. So a lot of people mistake the slope-intercept form for the slope formula. It is not. It is just the slope-intercept form. Why does it get this name? Because the m stands for slope, and the b stands for the beginning, but better known as the y-intercept. And so you get the intercept with the slope, slope-intercept form. Point slope, if you have the slope, you can actually figure out the y-intercept, but you can use this formula, y minus y1 equals the slope times x minus x1, where x1 and y1 come from some coordinate point that you've been working with. And m, again, is slope. The last one is standard form. It kind of goes like this: ax plus by equals c. Okay. Now again, we've really focused a lot on slope-intercept form probably in our math history due to its unique communication of rates of change and starting points. And so I'd like to point out one application problem. It says the graph below already shows a linear model for the first subscription of some company. Here's the formula: y equals 2500 x plus 3. Graph the line. For the second subscription, we're not going to do that. We're just going to focus on the subscription company number 1. And what we'll notice is that we have a y-intercept at 3. So this is your y-intercept. And essentially what happened is each unit, it only went up by a quarter. And so over the course of 4 units across and 1 unit up, the delta y over the delta x would be 1 over 4, which is how they get the 2500ths. Okay, so hopefully this is a good reminder as to how coordinate points work, how the Cartesian plane works, slopes, a review on the formulas themselves, slope-intercept lines, and we're going to begin a unit that really hones in on some of these skills. Thank you for your time.